Hey everybody, this is Larry. This is day 29 of the Leetcode Daily Challenge. Hit the like button, day 30, whoops, of the Leetcode Daily Challenge, whoops. Hit the like button, hit the subscribe button, join me on Discord, let me know what you think about this farm. Today's farm is 797, or perhaps from source to target. So this does not seem like a heap problem, probably. I'm probably going to do an extra bonus question after this, so definitely, if you haven't already, definitely hit the subscribe button. If not, then or if you already did, then we'll do an extra problem together, just in time for the weekend and New Year and all that stuff. Okay, so what is this? So it's a directed graph. It's a DAG, in fact. So yeah, we have end nodes and we have defined all possible paths. Okay, and we turn them in any order. Okay, I mean there are a couple of ways you can do this, but the the thing to note is that what is so one thing is that the first thing to notice is that it asks you for your all possible paths, and when you see things that requires all possible path, it's reasonable to assume that you're probably just doing some kind of brute force, as long as you're as long as you're not being ridiculous about it, it should be okay, because that's the size of the output. The size of the output will be your lower bound regardless of whatever, right? And of course, those people who are familiar with dynamic programming, there is a similar thing which is count the number of paths, and that could be solved with dynamic programming, and especially in a DAG, well, more specifically a DAG. And as part of that, you may record that if you have if you have n over 2 nodes and you have 2 paths, let's say you're allowed duplicate paths, then it's going to be 2 to the n over 2, so it's going to be exponential is kind of one way to think about it. And of course, even if you don't, you can think about like some kind of Fibonacci you have a linked list of n nodes, and then something like this, right? You have a Fibonacci of n nodes, and then you just have 2 edges going out, and that'll give you an exponential running time anyway. So yeah, let me take a look at the constraints, and n is only 15, so I guess even the worst case, it should be okay. So we just have to be careful, and yeah, the way that you could do it in a couple of ways. You can you could do it with breadth first search and then kind of path reconstruction exponentially, or you could just do it with depth first search, which is, I think, what we're gonna do, because you just basically try everything. Yeah, what are we given? Well, what is the format that we're given? So so graph sub I contains all the nodes that are connected to from I suppose. So so yeah, so then we have a depth first search. Right, so we have a current node, and because this is a DAG, we don't have to worry about like the parent or things that you've seen, but maybe we want to care about the current path that we are taking. And then basically, if node is, are we going to node -1? Okay, I just want to make sure it wasn't like all paths to all nodes or something. Okay, so yeah, if node is equal to, okay, so n is equal to the length of graph. So if this is equal to n-1, then we return, but we have a path, so we put it into the answer, right? And keep in mind that this thing is not a typo. It is to make another copy of the path in case you want to manipulate it. Okay. Otherwise, we just do a for loop, right? For each edge that we're connected to in graph of node, maybe this is a V. We just want that first search the V, and then path, except for we want to append the V, and then path, we want to pop it afterwards. Maybe we could also just, depending on how you want to do it, but yeah. And that's pretty much it, I think. So we just that first search from 0, and let's give it a spin. I forgot to write the path, which is the thing. Yeah, and of course we're wrong. Okay, we didn't put in the first one, I suppose. First node. Okay, we're close enough. So let's give it a submit. Hopefully I didn't make a typo, but yeah, looks pretty good. Looks pretty quick. 1,004 days streak, 4-digit days. Yay. Yeah. What is the complexity here, right? As I said, it's going to be exponential. It's going to be. There really is no way of expressing. I mean, we kind of went a couple of upper bounds as we said before. Given that n is equal to 15, you can maybe just say 2 to the 15 is probably. I mean, 2 to the n is exponential is probably good. Like I said, you could do a Fibonacci type thing if you want, and you can get a little bit worse from that. But in fact, I think 2 to the 15 is the upper bound in that you just have a full graph. And if you have a full graph, then you can look at each node as being other than the first two, so 2 to the 13 if you want to be strict on whether it is in the path or not. So then you have 2 to the 13. Of course, the first node and the last node has to be in the graph. So, but either way, it's going to be 2 to the n. But as I said, you can't be faster than that because, because you have to look at the answer. And technically, this is n times 2 to the n because that's the actual size of the output. If you want to be precise because of this thing, and this is O of n in the number of paths, number of nodes in the paths, and this gets called 2 to the n times. So this is actually n times 2 to the n. And in terms of space, it's the same thing because that's the lower bound that we talked about before. Cool. That's all I have for this one. That's all I have for today. Let me know what you think. Yeah. Stay good. Stay healthy to good mental health. I'll see y'all later and take care. Bye bye.